Okay, sorry everybody for yesterday. We had some technical difficulties and my computer just decided not to work. But we are back today, so I'm going to record this webinar and send it out to everybody. So thank you for everybody from the Body Barn that was turning up, and I know there was going to be more people turning up from outside, but I will send this to everybody that was going to be turning up. Okay, so today is going to be about measuring and mastering blood glucose. So firstly, I know quite a few of you probably don't know who I am. So my name is James Eagle. I am a human performance specialist. So I used to be a personal trainer a long, long time ago. So I've been in the fitness industry my entire adult life. So I've done everything from managing supplement stores in Canada to working on the gym floor to personal training. And now I analyze people's poo and blood and saliva and urine and basically anything we can extract from your body. We can analyze it, determining what is holding you back, remove those roadblocks, and allow you to perform to your highest potential. So now I work with everybody from professional athletes in Premier League football to desk jockeys just sat at home trying to better themselves. So I'm also a phlebotomist, so I can obviously take people's bloods to analyze it. I do nutrition plans for people, supplementation plans for people, and obviously, still being a strength coach, I still do exercise programs for people as well. So that's a little bit about me. But what I'm hoping to get out of this webinar, or for you to get out of this webinar, is a bit more of a better understanding of what blood glucose is and what it does in the body, the interactions of hormones and blood glucose, how to measure blood glucose properly, if CGMs are a good idea. So CGMs are continuous blood glucose monitors, and these are things like companies like Zoe. And then at the end, we're going to go through how to manage your blood glucose. Okay, so it's going to be quite physiology heavy. So throughout my career as a personal trainer, I got very into physiology, and then I started getting into functional medicine. So this is how I've learned how to do blood work, stool analysis, all these kind of things. So physiology is my passion. So I'm going to get into some physiology for you, but I'm going to try and make it as simple as possible. But I feel if you have an understanding of some of the mechanisms behind things, then you're going to understand my recommendations at the end. Okay, so first of all, what is blood glucose? So first of all, glucose is carbohydrate in its smallest form. So as you can see here, these are carbohydrates, and this is carbohydrates that are very small. So this is glucose. And then blood glucose is glucose in the bloodstream. Physiology is easy. Okay, so it's going to get a bit harder. So that's what glucose is. So basically, the smallest form of a carbohydrate is glucose. Glucose in the bloodstream is blood glucose. So what we have to know is that we have three main macronutrients, which are proteins, fats, and carbohydrates. Only two of these macronutrients are essential to the body. So by essential, meaning we have to get these through our diet, otherwise we will die. Okay, so we need to get certain amounts of protein through the diet. So we need essential amino acids. So these are the smallest constituents of proteins. These have to be consumed via the diet. And then from fats, we have essential fatty acids. Again, these have to be consumed from the diet. Carbohydrates, there are nothing essential about carbohydrates. So there's nothing essential about carbohydrates. So this is why it can often be wiped out of people's diets and people still survive. So this is why things like the ketogenic diet can exist, or the carnivore diet can exist, which has been popularized recently. Or obviously you can just go very low carb. So carbohydrates are not essential to the body. However, they are actually so essential to the body that the body makes it itself. So via something called gluconeogenesis. So gluco meaning glucose, neo meaning new, genesis meaning creation. So this is the creation of new glucose. The body can take other substrates such as glycerol or lactate, and it can turn it into glucose. So the body does need glucose, so it is very important. So it is important to get it from the diet, which I'll explain in a minute, because it is useful for so many different systems and organs within the body. So this is just a few of the systems and organs that utilize glucose as its primary fuel source, and more importantly, its preferred fuel source. Okay, so the body will make glucose if you don't consume it, but it's not going to make that much. It's only going to make enough for you to survive. It's not going to make enough for you to thrive. So for example, the brain will use around 120 grams of glucose per day. So if we aren't eating glucose or we aren't eating carbohydrates, the body will make some, but it's not going to make enough for you to thrive. So this is why if you go on, for example, a ketogenic diet, the brain will then start using ketone bodies or ketones instead of glucose because you don't have enough carbohydrates around to produce the glucose. So if you are looking to maximize for your performance, if you're an athlete and you are looking to maximize performance, you need carbohydrates around because it is your body's preferred fuel source and it is the primary fuel source for a lot of these systems and a lot of organs. Okay, so it is a very, very important macronutrient to have around. So how do the carbs you eat end up in your blood and stored as glycogen or the glucose coming to your body? So this is where we're going to get a little bit physiology heavy. So stay tuned and maybe get your notepad out. Right, here we go. So glucose is what we call a monosaccharide. So before we can absorb any nutrient, it has to be broken down into its smallest constituent. So for example, proteins have to be broken down into single amino acids so they can be absorbed. Fats have to be broken down into fatty acids so they can be absorbed. And carbohydrates have to be broken down into monosaccharides so they can be absorbed. So mono meaning one, saccharide meaning sugar. So here's just a list of some of the more common monosaccharides. So this is very handy to know. So for example, if you're an athlete, you're looking to fuel yourself during a game or during training, you want something that is going to be absorbed very quickly and be utilized as energy straight away. So this is where you will use, for example, if I'm making diet plans for football players, this is where I'll use things like glucose or fructose. I'll use these as a mix. So this will bypass digestion and get straight into the bloodstream because it's already in its final form. It doesn't have to be broken down. Okay, so this is also if you're running a marathon or if you have a long endurance event, this is why the glucose gels or just having something that is already broken down is going to minimize digestion and get straight into the bloodstream to give you energy. Next up, we have disaccharides. So I wasn't going to put this slide in. It doesn't necessarily need to be in. I just wanted to show you something on here that obviously gets demonized quite a bit, and I'm going to show you why it doesn't need to be. So disaccharide is just two sugars together. So there's just two monosaccharides bound together by a bond. So if we take one glucose and another glucose, bound them together, we're going to get maltose. And if we take one glucose and one fructose together, we're going to get sucrose. And sucrose is something that in social media gets a bad rap. But this only gets a bad rap because it is the sugar that is most commonly found in processed foods. But sucrose, there's nothing inherently bad about sucrose. Sucrose is found in fruits and vegetables and honey. It is found in a lot of things in nature. It just gets a bad rap because people see it on the back of processed foods and go, oh no, sucrose, we shouldn't be having sucrose. But if you know the biochemistry behind it, if you know it's just one glucose molecule and one fructose molecule, it is found in nature and there's nothing inherently bad about it. Okay, so this is why I put this in there, just to show you this. And when you see the suffix ose in nutrition, it is usually referring to a sugar. So if you look at the back of a packet and you see oses on the back, like lactose, maltose, this is referring to a sugar. And then we have polysaccharides. So this is how we should be consuming most of our carbohydrates. So this is obviously a lot of monosaccharides all bound together. Okay, so poly meaning many, saccharide meaning sugar. So these are all these little units are all bound together by these 1,4-alpha glycosidic bonds. And then this makes up a starch. Okay, so like bread or like pasta. And then we go on to the importance of chewing and de-stressing. So if we, for example, eat some bread, this is consumed in this polysaccharide form. So obviously all these little saccharides, they're all bound together by these little lines, which are 1,4-alpha glycosidic bonds. Within our mouth, we have salivary amylase, or more specifically, it's called 1,4-alpha salivary amylase. So we know which bonds it breaks down. So it breaks down these little bonds. So this is where the importance of chewing comes in. So we want to make sure we chew our food properly. So when we chew our food, we increase the surface area, and then enzymes like amylase can get onto the food and start breaking down these bonds. So there has been research in comparing chewing 15 times compared to chewing 40 times, and 40 times has been shown to increase satiety, so how full you feel, and it is going to increase the digestion as well, because obviously you have more surface area and then more time for this alpha amylase to get onto the polysaccharide and start breaking it down. And then the importance of de-stressing when you eat as well. So this is extremely important. So when we think of food, smell food, look at food, you often get that your mouth starts salivating or salivating. So this is called the cephalic phase of digestion. So this is just when we see food, smell food, this starts initiating the secretion of saliva and then this amylase. If we are stressed, then all of this dries up and this doesn't really take place. It just is very minimized. Okay, and then we'll have blood taken away from the digestive tract during stress and taken into the periphery of the body. So this is why it's important to de-stress before we eat. So this is, if you have digestion issues, this is the two things I'll look at first when trying to help somebody with the digestion. First of all, are they eating or are they chewing correctly? And number two, if they are eating in a stress state or not. So when we eat in a relaxed state, then we will salivate more, we have more secretion of this amylase or other enzymes, and then we're in a better place because we have blood into our digestive tract where it's going to allow us to digest and absorb these nutrients. If we are stressed, then the opposite happens. So if you're bouncing between meeting to meeting and you're stressed, there's a quick breath protocol that you can do has been shown to calm the nervous system and put you in a more relaxed state, which is going to allow you to digest and absorb this food. So if you just take 10 breaths, breathe in 3 seconds on the way in, 6 seconds on the way out, do that 10 times, that's a total of 1:30. And this has been shown to put you into a more parasympathetic state. So this is a more relaxed state, which this is going to allow you to digest and absorb your nutrients a lot better. Okay, so chewing and being calm is very important for your digestion. Okay, so once we have eaten this food, once we have swallowed it, then obviously it comes down through here, it goes into the stomach. There isn't much that goes on in the stomach in the way of carbohydrate digestion, and then it is dumped into the small intestine. So once it's in the small intestine, then we have things like pancreatic amylase is released into the small intestine to further break down these polysaccharides or these carbohydrates. And then we have things in there like maltase, which is going to break down maltose. We have lactase, which is another enzyme that's going to break down lactose. So if you are lactose intolerant, then you have a deficiency in the lactase enzyme. So this is why so lactose is obviously a disaccharide, so two monosaccharides bound together. And if you don't have the lactase enzyme to break those apart, then this is where you get things like gas or bloating because you can't absorb that lactose molecule. Okay, but once we do break it down, so once this is the brush border in the gut, so these are called enterocytes. Once we do break these carbohydrates down into their smallest form, so they're monosaccharides, then they can just be absorbed straight through the gut lining. And then once they are in their monosaccharide form, they have to be repackaged, otherwise they can slip back out into the gut lumen. Okay, so they have to be, once they come through in their smallest form, they have to be repackaged. And once they're repackaged, they are repackaged back into a polysaccharide. So lots of them bound together. And once this is packaged in the body, it is called glycogen. Okay, so when we hear about people trying to fill up their glycogen stores, like for example, the marathon that was a couple of weeks ago, people are consuming carbohydrates before the marathon to fill these glycogen stores up. So they break the carbohydrates down and they repackage them, and they are stored in our liver and in our muscles. So for example, an average person will store around 500 grams of glycogen in their muscles, and they'll store around 100 grams of glycogen in their liver. And then through glycogenolysis, this will break down the glycogen into glucose while they're running the marathon, and it will put the glucose back into the bloodstream, so then they have energy to run the marathon. Okay, so that's glycogenolysis. That's the breakdown of glycogen back into glucose so they can use it as energy. But glycogen is stored in a hydrated form. So this will be helpful in a minute for a top tip. So it's stored in a hydrated form, which means for every 1 gram of glycogen stored, we get 3 to 4 grams of water stored with it. So for 1 gram of glycogen, that is 3 to 4 grams of water stored with it. So this is where the top tip comes. So often when people are looking to lose weight, one of the big things people do is just they cut carbs. Okay, so they'll either go on just like a ketogenic diet or they go on a low carb diet. But if we refer back to the way glycogen is stored, so when you remove carbohydrates out of the diet, then obviously you start depleting glycogen that is stored in your body. So your body will use that up because it is the primary fuel source for a lot of systems, a lot of organs. So the body will burn through this before it burns through anything else. So it's going to burn through this glycogen. And obviously for every 1 gram of glycogen stored, you have 3 to 4 grams of water stored with it. So when that goes, when glycogen leaves the body, 3 to 4 grams of water leave the body as well. So you could lose around 3 kilograms of weight without losing any fat. So this is exactly what fighters do when they're trying to weigh in to get to a certain weight category. They cut carbs out of their diet, they start minimizing water. Glycogen then leaves the body, water then leaves the body, and they cut the weight, and then they can refuel to go into the fight to have an advantage over the opposition. But weight loss does not mean fat loss. So when you cut your carbs, if you see a significant drop in weight, that is not fat, that is purely just carbohydrates and water. So next time, if you are looking to lose a bit of weight or lose a little bit of fat, we should be saying, then just cutting carbs is not the way, okay? You want to just decrease overall calories, but that would be another webinar altogether. Okay, on to hormones and blood sugar. So hypoglycemia is having too little sugar in the bloodstream, and then hyperglycemia is having too much. Hypoglycemia, having too little sugar in the bloodstream, is going to kill you a lot quicker than hyperglycemia. So this is why we have 4 hormones that will put glucose back into the bloodstream. Okay, so the main one being glucagon. This was going to be the primary hormone that will put glucose back into the bloodstream. But then we also have things like the stress response. So you'll notice cortisol and adrenaline. These are all part of our stress response. So this is why if you are highly stressed, your blood glucose can go through the roof, because you are continually putting glucose back into the bloodstream because you are stressed. Okay, so this is still built in from biology from way back when we're getting chased by animals. So our body doesn't know the difference between being chased by an animal or you having a crazy work schedule. Okay, so stress is stress to the body, and the same hormones are going to be released no matter what. So cortisol and adrenaline are released. Back in the day, if a bear jumps out of us, these are released to put glucose back into the bloodstream so we have energy to run away. So the same thing is happening if you have a crazy work schedule. Cortisol and adrenaline are still being released and blood glucose is still being released, but you're not running away. You're just sat at your desk and your blood sugar is going through the roof. Okay. So back in the day, obviously, you would have burnt this blood sugar off because you would have run away. But now you're sat at your desk and you're just worried about work. And then growth hormone, this is often linked with fasting. So people will talk about growth hormone and the increase of growth hormone when people fast, and they say, oh, the increase in growth hormone must be anabolic when you're fasting. But the only reason growth hormone is released when you are fasting is because you are not consuming glucose, you're not consuming any carbohydrates to put glucose into the bloodstream. So one of the jobs of growth hormone is to prevent any glucose leaving the bloodstream. So it really packs the cells in tight, and it stops any glucose from leaving the bloodstream. So obviously it is raised because it doesn't want glucose leaving the bloodstream. But people correlate fasting with an increase in growth hormone, which does happen, but they don't understand the physiology behind it, which the only reason it is released is to stop glucose leaving the bloodstream because you're not eating. It is not there to build muscles. So people will say, oh, fasting is anabolic, and which anabolic means growing something, but it can't be anabolic because the only reason it is happening is because it's trying to prevent glucose from leaving the bloodstream. And the second point, if you are not eating anything, the last thing you're going to be is anabolic. Your body is not going to build something out of nothing. If you aren't bringing in raw materials to build something, which you're not when you're fasting, then your body cannot build anything. Okay, so just logically, it doesn't make sense, but that's social media for you. Social media tells you a lot of things that don't make sense. Okay, and then we only have one hormone, so insulin, to get blood sugar out of the bloodstream. Okay, so once blood sugar is in the bloodstream, once we get too much blood sugar or too much sugar in the bloodstream, insulin will be released and it will get rid of it. Okay, so we just have one hormone to get sugar out of the bloodstream. And so insulin sensitivity, so we have insulin sensitivity and insulin resistance. So this is what we want. We want insulin sensitivity. So we want this little come on in sign. So once we have a decent amount of sugar in the bloodstream, insulin will go and bind to a receptor on a cell. And through this, it will tell the cell to let glucose into the cell, and then it can go into the mitochondria. It can be turned into ATP, which is energy for the cell, and this can be utilized, or it can go off and it can be stored. Insulin resistance is when we have sugar in the bloodstream, insulin goes and attaches to the receptor, but one of the pathways is inactive. So it is resistant to insulin. It is not taking the signal from insulin and it is not letting glucose into the cell to be stored or utilized. So this is insulin resistance. Okay, so insulin is increased when glucose goes into or gets too high in the bloodstream. We have a quick question to see if you are still awake. You are not actually here. Okay, so you're not here, but you're watching it. So in your head, I want you to think about this. So think insulin is released when there is too much glucose in the bloodstream. So answer this question. If we were to infuse glucose into the bloodstream or eat a slice of bread, which would cause insulin to be released the quickest? Is it eating or is it infusion? Which one is going to increase insulin the quickest? Obviously, I can't see any answers, and I'm going to assume you said infusion, but you're wrong. No, so if you said infusion, that would make complete sense, and that's exactly what scientists thought. So it was hypothesized that it makes complete sense if you infuse glucose straight into the bloodstream, that insulin would be secreted straight away because insulin gets glucose out of the bloodstream. But sadly, they were wrong. So this is why they do experiments. So the reason they were wrong is because of something called GLP-1, which you've probably heard of recently, which I'll go into. But GLP-1 is an incretin, and an incretin is a gut hormone. So within your intestines, you have the sensors, and they basically sense when carbohydrates come into the system. And what they do is they release GLP-1. GLP-1 goes off into the pancreas. Inside the pancreas, we have these little pancreatic islets, and within these islets, we have these little vesicles, and they are full of pre-formed insulin. So once GLP-1 acts on the pancreas, then these preformed insulin cells will release insulin. Insulin will then begin to lower blood glucose. So that is why when you eat carbohydrates, you get a release of insulin quicker than if you were to infuse glucose straight into the bloodstream. Okay, and this is called the first phase insulin response. And this happens within 2 minutes of ingesting carbohydrates. And it lasts around 10 to 15 minutes. And then once the first phase is done, it goes into the second phase. And then this is just the pancreas creating insulin on demand. Okay, so you probably have heard of GLP-1. So there are obesity drugs called GLP-1 agonists. So these are things like Ozempic. But so this is just a few of the things that GLP-1 does, especially in relation to blood glucose. So it's obviously responsible for the first phase insulin response that we just saw. It makes peripheral tissue more sensitive to insulin. So all your tissue around the body will become more insulin sensitive. So then it's going to take in more glucose, and it is going to suppress glucagon. So remember, glucagon I said was the first hormone that is going to put glucose back into the bloodstream. So this is one of the important ones, that it suppresses that from happening. So obviously if glucose is coming in, you want to suppress that. But even if all this is working perfectly, obviously GLP-1, the agonists like Ozempic will help with this. But even if this is working perfectly, this is not why Ozempic or the obesity drugs work. The only reason the obesity drugs work is because they decrease your appetite. So you're not going to be eating more. So even if this was all completely perfect, but you are still eating more calories than you're burning, you are still going to gain weight. The only reason Ozempic or any obesity drug works is because it suppresses your appetite. So then you aren't as hungry. So you're not bringing in as many calories. So you can't get away from the whole calories in versus calories out. There's a law of thermodynamics. It's unrefutable. It will always happen. So if you eat more than you burn, you will gain weight. Okay. But then if you eat less than you burn, you'll lose weight. And that's exactly what Ozempic makes you do. Okay. And then this is just showing you the first phase insulin response. So this is the GLP-1. This is what GLP-1 does. It secretes insulin. So this is normal physiology. This is the first phase insulin response. So as you can see, insulin here, once you've eaten something, within 2 minutes, you get this spike of insulin, and this starts pushing carbohydrates or glucose into the cell. So as you can see here, this is glycemia. This is your blood glucose. The blood glucose curve isn't very pronounced, and it stays quite low and comes down nicely. where this is the pathophysiology. So this is the loss of the first phase insulin response. So as you see here, no first phase insulin response. Insulin just keeps climbing, and then look at the blood sugar. So you get a very pronounced spike and then it drops significantly. So this is where you're going to get crashes in blood sugar, and this is where you're going to feel energy dips. So the reason I show you this is because the first phase insulin response is one of the earliest predictors of type 2 diabetes. So think if we could measure this via, I know, some sort of blood marker, then this would be amazing, because this is going to tell us if someone is likely to get type 2 diabetes. And thankfully we can. So we have a marker called 1,5-anhydroglutathione. So this is a measure of glycemic variability, or more specifically, a measure of the first phase insulin response. So this can be measured in blood, and this is a measurement of glycemic variability and the first phase insulin response. So this is a very good marker to utilize on a blood panel. I'll go through some of these for you, but these are just some of the glucose markers that you can have on a blood panel. So first of all, fasting glucose. Obviously, this is just glucose taken while you're fasting. Non-fasting glucose, this is glucose taken when you're not fasting. Hemoglobin A1C, or HbA1c, you might have seen this before. This is a very popular marker and a very good marker. So this is when glucose is in the bloodstream. Obviously, it binds to a part of the red blood cell called hemoglobin. So the more sugar in the bloodstream, the more of this binding is going to take place. And this is over a 90 to 120 day period, because that's how long red blood cells last. So this is a marker of what your blood sugar is doing over a 90 to 120 day period. So it's a very, very good marker. And then we have insulin. So we can measure insulin, but this isn't actually as good a marker as C-peptide. So C-peptide, funnily enough, is a better marker of insulin than insulin itself. So it sounds crazy, but I'll tell you why. So in those vesicles I showed you within the pancreatic islets, you have preformed insulin. So when you create insulin, you have to go through, it starts as pre-proinsulin and goes to proinsulin and then turns into insulin. When it does this, it goes through, so it has a B chain, an A chain, and a C chain. When it goes through this transformation, the C chain pops off. This is called C-peptide. And then C-peptide and insulin are stored and secreted in a 1-to-1 ratio. So when insulin is secreted, C-peptide is secreted at the same time, at the same amount. The reason this is good is because insulin has a half-life of around 3 to 5 minutes, because it goes off to the liver and it gets metabolized, whereas C-peptide is metabolized in the periphery of the body, and it lasts for around 20 to 30 minutes. So we have a longer period of time to measure C-peptide, so therefore it is a more accurate marker of insulin. And then we have fructosamine. So fructosamine is basically glycated albumin, which is another protein found in the blood. And this is around a 2 to 3 week marker of what your blood glucose is doing. And then we have a HOMA calculation. So this is a calculation of what the beta cells are doing and what your insulin sensitivity is like. So this is the beta cell function within the pancreas, how well that is doing, and a marker of your insulin sensitivity. Okay, so how are these measured? So these are all measured in blood. So blood is the most scientifically validated marker we have for measuring pretty much anything. So this is why you can get a blood test done in Australia, New Zealand, in America, Japan, China, UK. Everywhere does blood, because it is the most scientifically validated way to measure things in the body. So if you go to the doctors and you're sick, this is why they'll send you for a blood test. And you probably had many blood tests, because it is so reliable and it is such a useful thing to do. But there are differences between normal reference ranges and optimal reference ranges. So each lab has its own set of reference ranges. So how they determine this is, people will go to the doctors will send the blood to a lab. That lab creates reference ranges based on the people it sees. So sadly, each lab has its own set of reference ranges. There isn't a universal one. So this is why people like myself have a job, because we go into the research, we find out what the optimal reference range is. So people who go to the doctors to get blood work done aren't usually the epitome of health. They're usually already sick. So the lab's reference range is based off a sick cohort of people. But if you go and find the optimal reference ranges, then you can find what is the desired reference range for healthy people. So normal reference range is based on sick people. optimal reference ranges is what you need to go into the research and find. So for example, on HbA1c, a regular reference range will go up to 42 millimolars. So this is one of my clients. This is just the regular reference range. And then I have my own optimal reference ranges on my computer. So this goes all the way up to 42, but the optimal reference range ends at 35. So once you get above 35 millimolars, this is when you can start seeing detrimental effects. So it's actually increases in all-cause mortality above 35. And increases in all-cause mortality means an increase in death from anything, which is crazy. So this client came to me, and obviously I saw 39. So we put him on a protocol to manage his blood glucose. But if he had gone to the doctors or he just went and just got this done himself, he would see that he's in the green and he would assume this is completely fine. Where in matter of fact, he is actually 4 points above the optimal reference range. So he's 4 points higher than where he should be. But if this was traditional reference range, they wouldn't intervene until another 3-4 more points. And by then, who knows what could happen. So with the optimal reference ranges, we are trying to intervene before something becomes an issue. Okay, so we are trying to catch things before they become an issue. Once you get to 42, you're going to start already having problems. But if we can keep you around the 35 mark, 33 to 35, then you're going to be in very good check. Okay, this is going to be the fun part for everybody. So what are continuous blood glucose monitors? So these are the companies like Zoe. These are little patches that you'll stick on your arm or into your tummy, and they assess the glucose in the interstitial fluid just underneath the skin. So this is actually a very good representation of glucose within your blood. Pardon me. So for type 1 diabetics, these are very, very beneficial because type 1 diabetics, they need to know what their blood glucose is doing constantly because they don't create their own insulin anymore because their beta cells within the pancreas have been destroyed. So they no longer create their own insulin. So then they have to administer insulin via an injection. So if their blood glucose goes too high, then they can know when to administer insulin. If it goes too low, then they can have something to eat to bring it back up. So these are extremely beneficial because beforehand they have to prick their fingers constantly and then their fingers start looking like pincushions, and that's no good for anybody. But who are they not good for? They are not good for everybody else. Okay, so the premise behind why a lot of these companies like Zoe exist is something called precision nutrition. So this is where they say they can take like your DNA or they can look at your continuous blood glucose and they can decide what you should be eating based on these markers. But I'm going to show you why that is complete nonsense. So first of all, when you are thinking about blood glucose, there are a few things that you can take into consideration, but I've made this acronym called TAM. So this is the type, the amount, and the mix. Okay, so the type of foods you eat is going to determine what happens to your blood sugar. So if you were to eat a carrot compared to eating a scoop of ice cream, the carrot is more likely going to increase your blood sugar higher than the ice cream. Because in the ice cream, we have protein, we have fats that is going to slow the digestion. So if people were to eat a carrot over a thing of ice cream and they were to see the carrot raised it higher, they may make the decision that a carrot is bad for them, which obviously we know is not the case. However, lots of ice cream, like this little rascal's eating, is going to spike your blood sugar a lot higher than just the carrot because the amount of something you eat is also going to determine how high your blood sugar goes. And then if you just mix these together, which would be pretty grim, but if you ate these together, you would get a completely different reading again. So that's the type, the amount, and the mix. It's just a few things you need to take into consideration when thinking about what your blood glucose is going to do. And also, obviously, labeling foods, good or bad, depending on how they affect your blood glucose, can have a very negative effect on how people view food. And I think at the moment, nobody knows what to know about nutrition because there are people on social media who are in supermarkets telling you that fruit is bad or vegetables are bad. And then there are people telling you you shouldn't eat meat. There are people telling you should eat cereal. Basically, nobody knows what to eat anymore. And if you add what your blood glucose is doing to determine what you should be eating on top of that, then I think it's just a recipe for disaster. But if going back to the carrot and the ice cream, if you were to determine that whatever your blood glucose does is the best for you, and you determined that an ice cream is better for you than a carrot, then you know things are off. Okay, so there's a lot of things to take into consideration. Also, if you are determining what is good for you based on your blood sugar, you would determine that exercise is very bad for you as well. So again, like I said, when we got back to the glycogen analogy with the marathon, when you exercise, your body goes through something called glycogenolysis. This is the breakdown of glycogen, putting glucose back into the bloodstream to fuel you because you need that energy. But if you were to wear a continuous blood glucose monitor, you would see that exercising spikes your blood sugar through the roof because you need that energy. And if you're determining what is good for you based on what your blood glucose does, then exercise is also going to be bad for you. And then you just got to know that it's not inherently bad to have spikes in blood sugar. We have mechanisms in place to manage this. So it is completely natural, it's completely normal. You need spikes in blood sugar. We are designed to have this. It is not inherently bad. It is only bad when it gets chronically high for a long period of time. Okay. And then if you still think glucose monitors are a good idea, let me show you these two papers. So this first one, this had subjects in a study. They wore two separate blood glucose monitors from two different companies. Everybody ate the same meal, and both glucose monitors had discordant readings. So they had different readings to one another. So that just shows you that from one company to another, you can have discordant readings. And then in this paper here, this was a very, very good paper. This was done recently. So this is a metabolic ward study. So they had participants in there for 2 weeks. So metabolic ward, they control everything. So everything is very, very controlled. They even took pictures of the food. They weighed the food down to the gram as well. So this is extremely controlled study. So week one, they served them breakfast, lunch, and dinner, all the same meals. Everyone's wearing a continuous blood glucose monitor. The next week, they had them eat the same meal on the same day at the same time, and the people got a completely different reading compared to the first week. So the same meal got a completely different reading from week one to week two. And it was so different that it looked like they were eating a completely different meal. So this just shows if you are trying to determine what you should be eating based on your blood sugar, it is completely impossible. Because even in a metabolic ward study where they control for absolutely everything, they can't replicate the same blood glucose measurements. Okay, so try it. So if you are trying to determine what you should be eating on blood glucose monitors, stop it. It's not a good idea. So just because you can measure something doesn't mean you should. And I'm not sure who said that, but I'm sure it was somebody smart. Okay, so now going on to, so it's not all doom and gloom. Now going on to how to manage blood glucose. And so when we're trying to manage blood glucose, the best thing to do is start with the lowest hanging fruit. Okay, so the lowest hanging fruit is, for the first one would be energy balance. And so this is just calories in versus calories out. If you are, for example, if you are overweight or you are eating too many calories, if you can bring these calories down or just try and lose a bit of weight, this is one of the best things you can do for your blood sugar management. Okay. And then exercise, obviously, if you're at the body barn, keep crushing it. This is the way to go. Footballers, keep doing what you're doing, but exercise is very, very important. So there's something called non-insulin mediated glucose uptake. So this is glucose being uptaken into the cell irrespective of having insulin around. So when you exercise, your bodies will take all that glucose in irrespective of having insulin around. So it is very, very important to exercise. So exercise is brilliant for a lot of things, but blood sugar management, it is amazing for. Sleep. So just a few nights of crappy sleep can really affect your blood glucose management. So trying to obviously get good night's sleep, trying to get the 7 to 9 hours of sleep, make sure you're having good sleep hygiene, going to sleep at the same time every day, waking up at the same time every day, sleeping in a cool room, make sure it's dark, all those kind of things. But sleep is extremely important for blood glucose management. And then obviously stress management. So like I said before, if your stress hormones are through the roof, make sure you keep an eye on your stress because it's just going to keep putting glucose back into the bloodstream. And again, this is bad for your blood glucose. And so these are the things you can tick off. And as you can see, these are pretty much all free. Okay, so trying to tick these off first is the best thing you're going to do. And then you can get into things like supplements or looking at your blood work. But these are the things I would recommend ticking off first. Okay, fiber. Sorry, supplements. So there are quite a few supplements that are brilliant for blood glucose management. Um, I'm only going to show you two because the other ones I will talk about them, but they have to be very specific and they are normally dependent on what your blood glucose markers are doing from blood tests. So fiber, nobody gets enough fiber in. I think on average is only 13% of men and 4% of women meet the daily recommended amount of fiber. So this is in the UK. So this is very poor. So we want to be aiming to get around 25 to 30 grams of fiber per day. So fiber is brilliant for blood glucose management. And if you can't get it in, then things like beta glucagons or psyllium husk, these are just be powders you can stick into smoothies, on yogurt, and it's just an easy way to increase your fiber. And then we have things like berberine. So berberine is a wicked herb for it is antimicrobial, antifungal, it's brilliant for gut repair, it's brilliant for a lot of things, but it's also amazing for blood sugar regulation. So there is evidence from clinical trials that say that berberine is just as good as things like metformin, which are very powerful medications for blood sugar regulation. So berberine is wicked, but it wants to be divided up into doses throughout the day because it does have a half-life. And then there are other supplements like cinnamon or fish oil or GABA or magnesium or zinc, but these all have different things that they do in the body. So some work by mimicking the effects of insulin, some make you more insulin sensitive, some suppress glucagon, some increase GLP-1, and some are just involved in glucose metabolism. But I don't want to start putting these out there because this is really going to be based on what your blood markers say or what is specific for you. So what should you do? So my recommendation before doing anything is just knocking off the lowest hanging fruit. So get your energy balance in check, make sure you are exercising regularly, make sure you're sleeping, and try and get your stress under control. So these are going to be the biggest bang for your buck. So supplementation, all that kind of stuff is brilliant, but nothing is going to affect your blood glucose management like these four, and they are free. Okay, so try and knock these off. They are going to have massive effects. And then if you want to go any further, then I do have the Health MOT. So this is probably one of my most popular packages. So this is a blood test. This will look at all your blood glucose markers. This will look at red blood cells, white blood cells, your immune system, your liver function, your kidney function, what your hormones are doing, your metabolic markers, or your cholesterols, what your fats are doing, how you metabolize certain foods. This Health MOT is, yeah, like I said, my most popular, and it comes with a lot of in-depth questionnaires. So you will find a lot about yourself from doing a specific blood test. And then obviously, like I said before, if somebody is running you through the optimal reference ranges, like I do, then you're going to find a lot more about yourself than just looking at the normal reference ranges. And then you will start correlating different markers with other markers. There's so much that goes into high performance blood analysis, and this is what I do. So if you wanted to get into this, then I'm more than happy to help you. And do you have any questions? You can't put them in the box, but if you do have any questions, then please feel free to I was going to write it down. Feel free to message me at james@jameseaglefitness.com. That's james@jameseaglefitness.com, and I'll help you with any questions that you have. If you want to know more, just let me know, and I'll do my best to help you. But hopefully that has been informative and helpful. And if you have any questions, like I said, please send them over. And thank you very much for your time. Have a good evening. Cheers, guys.